right, hello everybody. Let's just make sure that I have everybody on mute so that we can have a great connection. Again, welcome everybody. Delighted to have you join us today. For those who don't know me, it's okay, you're excused. I'll introduce myself very, very briefly. My name is Ankuta Vaisa. I'm a sales leader, revenue builder, creating all sorts of naughty things in the corporate environment in terms of sales leadership. I am mentoring with Women in AI and volunteering and a part of our education team together with Toma. I'm super delighted to welcome everybody today as we kick off our week 2 of our May series around responsible and ethical AI in practice. So Toma is going to run a practical session on spotting bias in AI systems, and this is really designed for anyone working with AI. What it is that you can expect is really, to get a glimpse as to where bias actually enters AI systems and where it usually goes unnoticed. And we'll be looking at a hands-on audit framework that you can run on your own work. So that is about today's session, pardon me. And as I was saying, Toma is going to be running the session for us today. She is a data scientist and AI practitioner with over 10 years of experience, and she's specializing in machine learning, intelligent applications, and data-driven problem solving. Toma's work focuses on the gap between what AI can do in a demo and what responsible deployment actually looks like in practice. We know there's a big gap between those two elements. She's also a volunteer with Women in AI Ireland, and she's actively mentoring and supporting initiatives that promote inclusive participation in AI. Again, welcome, Toma. Stage is yours. Thank you.
Thank you, Ankuta. I'll just share my screen now.
Please.
Sec. I'm sharing the right thing. Are you able to see my screen?
Yes, we are.
I'm sharing the right thing, yeah. And it's the slides, right? Okay, grand. Okay. Thank you so much again, Ankuta, for that introduction, and welcome everyone. I'm Toma. I'm a senior data scientist. I'm usually on the other end of the call, typically, because I volunteer with Women in AI as well. But today, I will be taking us through a practical way for us to kind of spot bias in our AI systems that we are building. So I also build systems. I'm a developer, an engineer by training. So whether you're building or you are, just using an AI system, the goal really for this session today, a short 30 to 45 minutes will be together. We'll be to, have at the end of it, a practical way for us to kind of audit our systems that we use, right? So again, my name is Toma, for those who do not know me. And so, right, this is a good place, I think, for us to start, right? Because bias in AI isn't theory anymore. It's basically production reality. These are two systems I just thought to highlight to kind of give us some context. The first on the left here is a healthcare risk scoring algorithm. This was built by Optum back in 2019. It was used by hospitals across the US to decide which patients should get extra care, right? And so the algorithm was designed to identify high-risk patients who needed extra care. Because, of course, that health need is hard to measure directly. Here, the developers of this system used healthcare costs. So basically how much a patient was spending, it's a proxy to determine the need. And you can kind of have an idea of what will go wrong there, right? If they're using just the cost. But because of the way the system was set up, the math was perfect. And, using its proxy, it accurately predicted who was spending more money. over the course after the system had been deployed. I think some of the records show it was used for over 200 million Americans. So again, think of the massive scale of that system. But when they had a closer look at it carefully, they found that it was underserving Black patients. Why? Because essentially the algorithm used healthcare cost again as a proxy for need. And historically, less money had been spent by Black patients in the US, really regardless of their health status there, right? So the system was prioritizing healthier white patients over sicker Black ones because it mistook wealth for health. Here, the key failure there was that the model had learned who needed care, um, basically again by looking at cost and at that massive scale that we discussed, over 200, about 200 million people. That really meant a generation of inequity quietly eroding into a model that had passed like technical checks. At some point, Optum disputed elements of the analysis that were done, but underlying that really was that cost had been like racially loaded, had basically served as a racially loaded proxy, right? Um, and on the right, we have like a different system. So if you're familiar with, machine learning models, you will know like the predictive, classical traditional machine learning models where you're basically feeding in some data that you have to make some predictions, right? So here we're feeding in cost to get, health needs. But now we have like generative models, the new ones, but the bias problem has not changed, right? It's basically just shifted to a different type of model. And this is an example. Again, in 2024, researchers tested an LLM-based resume screening system, the kind that nearly all Fortune 500 companies are now using to evaluate candidates, right? They ran controlled experiments on these systems where the variables used were like the candidate's name, right? And then the result of that, again, the system favored CVs with white associated names in over 85% of cases, consistently disadvantaging Black male candidates specifically, even when their qualifications on paper were basically identical. Now, this isn't a single bad model, right? It's a consistent pattern we've seen across several systems. And I'm sure, if we even do a quick like check of the room, a few of us will also have had several experiences working with AI systems, right? Again, this is just like two of many. If I can recall a few, UNESCO documented a couple of years ago, I think in 2024, that major LLMs describe women in domestic roles 4 times more often than men, right? A very popular case, Amazon with their AI recruiting tool. If you had been following the gist, I think this was also a couple of years back. They had to scrap that recruitment tool. After running several audits, they found it was again penalizing CVs from women, downgrading applications that included the word women, right? So imagine someone who probably went to an all-women's college. The model had basically learned from years of male-dominated hiring decisions to downgrade those applications. There have also been studies, right, revealing with algorithms that deliver ads, some algorithms showing STEM career ads to fewer women than their equally qualified male counterparts, right? Basically not because of any explicit rule, but because the targets that were set for those models, the optimization target set really um, and men engage more with such ads. So if the model is optimized for those targets, engagement targets, it will serve more ads to men than women, right? So here again, models just basically replicating the biases, the gaps that we have, over time. And one I think we can all relate to very well. I also ran a few tests of these, where with the text to image generation models, we find that, they amplify occupational gender bias, gender stereotypes at scale, right? So think of prompts that contain words like CEO or doctors producing, images of men. And then when you prompt with nurses, you get images of women, even when the prompts are very identical. If you say very really no variance, regardless of what you have in the prompt. Yeah, so there are several um, research studies that have shown these patterns is really everywhere that we've looked for it, right? And so this brings us to like a hard truth, right? The systems we've seen over time, they all pass their technical checks. The maths was right, the models were optimized, right, for whatever metrics they were being measured on, for their performance. If it's accuracy, they were optimized for accuracy, but the logic there in those systems was wrong. We say like the logic was wrong when we assumed that healthcare cost equals healthcare need, right, in the Optum case. Also, when we assumed that a model trained on historical data would suddenly stop mirroring those historical prejudices, right, like the resume screening examples that we saw, or our image generators, returning again pictures of men when they're asked for an image of a CEO or of a doctor, right? So, the systems, they passed their technical checks, but then fundamentally they failed people. And what we can learn from these cases is that we don't really need better code, right, when we're talking of the issue of bias, but we need a better process, a better audit process, a structured way to interrogate the assumptions that we have or the assumptions that the data that we feed into our model has, right, before we can even begin to deploy a single line of code in production. And so that again, that is what really this session is about, right? Not particularly about whether AI is biased. We already know that it is. We've seen it clearly over time. And I'm sure, as I said, some of us will have a few experiences. Hopefully, you can share some of them with us toward the end of the session. But our focus this evening really is about how you as you use AI systems, either in your roles or your personal work, how you can actually check for some of these issues. Now, to start with, we need to kind of have a shared picture of where bias enters into a system, right? Where bias lives, basically. And it's not just a problem with the model. It can exist at several stages of the life cycle as data flows through our models, our AI models that we're using. And so if you're auditing only on like your model output, already, you're getting some key things wrong there, right? And, at the beginning, I had made that distinction between predictive and, our new generative systems. We saw bias in both cases. But for predictive models, because these systems are much older, we kind of have like several playbooks, several frameworks that have formed over time to help us, detect and correct biases in those systems, right? A few of them you might be familiar with again. The the NIST AI Risk Management Framework. I don't have it up here, but that is like the US government's framework published a few years ago for identifying AI risk across like the full system lifecycle that has been widely adopted by several enterprise teams. Here in the EU, we have the EU AI Act, which basically mandates bias testing, particularly for high risk systems. So think of systems with like hiring or credit scoring, or like in healthcare sectors. Those are mandated by law. Bias testing is mandated by law in those systems. Microsoft and even IBM, they've also like open sourced a couple of frameworks as well. Microsoft, I think theirs is called Fairlearn. It's just a toolkit for measuring disparity among groups. But that one is particularly for like predictive systems. IBM also has like their Fairness 360 framework, which again you can use to kind of measure fairness metrics and bias mitigations across like a broad range of metrics that they cover there. So those cover the ML pipeline. But for this talk, we'll kind of focus our attention on our generative and agentic systems. Hopefully, try to again have a practical way to audit those systems, right? Um, so think generative systems are RAG pipelines that we're constantly currently developing, agents that can take action and learn from their environment, right? The thing with these new systems is that the technology is evolving so quickly. And so our way of, you know, spotting issues in this system also has to be like really quick and really fast, right? So that we can quickly iterate, particularly when we have like new tools coming out, we want to quickly test them and see how they work for our use case. So part of that testing process has to include, this bias audit. And so, which is why I kind of designed the canvas. I call this a practical canvas, and we'll see it later on. I designed that to be like something that you can use to really very quickly check whatever systems you are either building or using, right? But as I said, first, before we even talk about like auditing, we have to understand where bias enters, right? And this is just kind of a life cycle of the way data flows in our generative systems. Because again, we want to kind of trace where bias enters, right, into the system through the data flows. Here we have 5 stages. First one, pre-training. This is where the model learns, its world, right? So it reads data for our text generative models. It learns, it listens, right? If you're working with an audio model, or it watches, so a vision model, it's sees like several videos, right? But it's basically underlined that a corpus of data that the model builds its understanding from, right? So these are foundation-based models. So think Gemini, Claude, GPT, whichever one you're building your stack on, Grok or Meta's Llama model, right? The critical question here is it really what the model learned, right? Is typically who was represented in the data that the model learned from. And I just put a simple example there. Hopefully, again, we can all kind of relate to this. Our voice recognition systems that are trained predominantly on American English, they there were like several viral moments in the news where these systems were found to perform worse on Scottish accents, particularly Scottish accents, right? Alexa failing to understand Scottish speakers in their own homes. The system again wasn't broken. It was working exactly as it was trained, as you can imagine, but the training data had a particular shape, and then the model faithfully reflected that shape that it had learned over time. Second stage is alignment, right? So after pre-training, this is where humans now begin to tell the model what a good response or a good answer looks like, right? So it's called alignment, that phase. And so typically you will have specific humans or labelers who, who look at each model output and, label good or bad and feed that data back into the system for the system to learn from. Again, another place where data is coming in and another source for, any type of bias um, if our like labelers here are not like diverse enough to capture like several different perspectives, right? Third stage is with retrieval. So for those who are building, particularly RAG systems, bias can enter through the retrieval corpus, right, that the system searches during runtime. So whose documents get indexed, right? An example here, maybe in hiring again, think of RAG built on a company's past resumes. That encodes the company's past hiring patterns. And so the retrieval layer, again, is also a representation choice. The AI is only as inclusive as the library that you are allowing it to read from. Next, we've got generation and action. This is the stage where the model now interprets a prompt, right? We talked about like image generation, text to image models, example where you give it a prompt like CEO and it defaults to returning images of men, right? So the system again isn't hallucinating, it's basically relying on common patterns that it knows because the prompt itself didn't give enough context, it didn't provide enough context. And also like for agentic systems that take action, this stage would also include like things like tool calls. So any external tools that your agent is calling, think of maybe if it has access to your emails to read or send emails, that's another place where you can have, issues, right? So the agent's behavior can vary by user in ways that you typically wouldn't have been um, um, very visible. And then of course feedback, which was like the final stage. Generative systems produce content. That synthetic content now floods the internet. I think that is like we're using AI systems, we're using LLMs, we're generating content on a regular basis, every second. That synthetic data is now like going back into the internet. Data from the internet is basically what's scraped and fed back into the next generation of models, right? So we're effectively building a loop where today's AI bias becomes tomorrow's ground truth. And then again, if you're thinking agentic systems, the agents take actions, and those actions that they take will produce some data that the agent then reads. This again reshapes the world that the agent observes. And so any bias, if it exists, it doesn't correct over time. It basically compounds because as the agent takes action, it generates data, it gets back into, you know, feed into like the agent's input for further actions it takes down the line, right? So that just compounds this. Now, so for each of these stages is a place where bias can hide. And so while the instinct, as I said initially, might be to just look at the output of our models, particularly for generative models, we need a systemic way of investigating each stage because the problem might be hiding in the ones that you skip, right? And so one key lesson that we've kind of learned over time, again, just to kind of set like context here before we go into the canvas, one key lesson over time, and this translates from like our traditional machine learning, models, traditional systems to now generative AI, is to always disaggregate our data, right? Think about what we tell ourselves about how a model is performing. We could say things like it's 85% accurate, or it's scored highly on a benchmark, right? Or, generally the user satisfaction is very good, right? These are all sentences with like the subject removed, right? And so if we say, for instance, 85% accurate, that accuracy, that a metric is for who, right? Aggregate numbers like those are kind of dangerous because they are designed to hide like the edge cases. So again, an example, if you think of the voice assistants that we talked about, it can have an average accuracy of 95%. That sounds like a success. It sounds good. But if you then begin to disaggregate the data, you might find that it is maybe 99% accurate for American English and only 60% accurate for Scottish accents, right? So that 95% accuracy average score, it's functionally correct, but not correct for like the average Scottish user. They can relate to that, right? For generative systems, that means, we want to basically break down the, whatever metrics we're measuring our system on, right? So think of like the quality of the generation, either text or images that are being generated, the frequency of refusal, so how many times the system doesn't respond. Like, so for specific users, is that frequency of refusal higher than others, right? Even like the length of responses that the system gives, or one popular metric is helpfulness, right, of the suggestions that the model is giving. If we break that down by language or by demographic markers, and by use case, we may begin to now see, you know, certain other nuances in our data. So always you want to kind of disaggregate by groups. It's really I said here, it's a single highest leverage habit that you can kind of build, right? So whether you're a developer or you're just like a user or a product manager or someone who's buying an AI system, essentially don't accept like the general 90% helpfulness score, right? You want to ask for scores disaggregated by either language, region, demographic, things like that. And so the canvas, again, I built this to be like a very quick, easy check for us, and also designed to be accessible to every single person. So whether you're in a technical role or not, right? Everything we've discussed so far kind of leads up to this point. It's distilled into 3 quick checks that you can do. First, who's missing? That's the first question. Next, whose defaults are in, and we'll see like more details of all of this, right? But if we're talking of who's missing, that's basically talking about the inputs to our systems, right? So think the training data, as we saw in our life cycle, either training for like RAG or even pre-training for our foundation models, the alignment preferences that are built in. It's really about representation here. This basic question is asking like whose voices, whose perspective are built systematically into our system, and then whose voices are left out. The second check, whose defaults, right? This is now about reasoning. So it looks at interpretation, authority, and action here. When a system is given a vague prompt and it has to fill in the gaps, which it constantly has to do, whose assumptions does it use? Whose claims does it treat as authoritative or not? For agentic systems, you are asking there, what is the agent allowed to do for each of your user sections? And the final one would be failure modes, right? This is really about the outcome. So we've looked at inputs, reasoning, which is somewhere in between, and then like the outputs, right? So you're looking at here at output quality. For agentic systems, again, how like bias compounds over multi-step chains, and then your feedback loops that we talked about that you're creating, those compounding efforts there. And it's also, let me see, right. Okay, and so it's also available on my website. I put a link there. You can have a look. It's much more detailed than the slides and also contains a few examples. So hopefully that would be like easy to really apply moving forward. But if we're looking at the first check, right? Who is missing? Who's missing? As I said, this first question is really our input audits. It's about representation. The first question there are 4 questions in each of these different ones broken down. The first question there is whose data was the model trained on? Whose languages, dialects, and perspectives are over or under represented in that training data. So we know for most of us, we are using the foundation models, the GPT, Gemini, Claude models. These were trained on massive slices of the internet. But then which dialects, which perspectives are buried in the noise of all of that like massive data? And so for most of us, the answer there will be that we do not really know what data our models that we're using are trained on. right? But again, it's just to kind of surface things like this, right? So you just know that you're not aware of that. That now gives you information moving forward to like review against like your user base, right? For RAG systems, where does the retrieval couples come from, right? So if you're building a system, key again to look at like that data that you're collecting to feed into your system, right? So an example, if you're building like an HR assistant using a corpus of like past hires, you are basically effectively replicating any bias within the company's current data, right? The critical follow-up question there will now be to ask, would those missing data points or those missing voices, would they change the answer of your system? Yes or no, right? So if the answer to that is yes, then you know you have like a gap that needs to be addressed, right? And so as I said, like the full canvas it includes 4 questions for this check. I'm just anchoring here and focusing on pre-trading and for RAG. The other 2 questions include, something on, I think, alignment. That's for people who told the system what a good answer looks like. And then like our system prompt, which basically defines, the safety guardrails that we put in place our system. Next, whose defaults? Just looking at the time. Okay, whose defaults? Again, simple, quick question we can ask that can surface certain things there, right? We've audited our inputs, the data, our knowledge base for our RAG systems. Now we have to look at how the system actually thinks, right? And that's what this second question is about. The first question here is asking, when the user is vague, what does the system assume? And this is a test that like each and every one of us can run on whatever system that we're either using or developing, right? But the key thing here is you don't find those answers by like reading a technical spec. You basically find it by like poking the system, poking the model. You want to run like several stress tests and send maybe the exact prompt multiple times, swap out several demographic markers as we discuss disaggregating, and then see how like your responses shift there, right? The second question is really for agentic systems. Here you're asking what is the agent allowed to do and for whom, right? Does it act autonomously for some users and then for other users requires human approval first, all right? This is, I think, the most agentic failure mode in the canvas. An example here would be like a loan agent that auto approves certain applications and then others it routes them for review. You want to kind of ask like why, and are there any patterns that are forming there, right? Or again, hiring agents that draft, interview invites for some candidates and then for others flags them or rejects them. Or even, you could also think of like customer service agents that resolve some tickets directly and then escalate others, right? The question isn't whether like having autonomy, again, for agentic systems, the question really isn't about whether having autonomy is bad, but rather whether the threshold for your autonomy varies in patterns that reflect bias in your system, right? Again, there are 2 other questions contained there, and you can kind of check them out. I try to stress test Gemini a bit to see how it behaves. I was actually quite pleased to see that some of those patterns and bias that we had seen over the years had kind of been resolved, right? So that CEO example that I kept giving. Now, if you ask Gemini to give you an image of a CEO, it gives you like a very diverse output, right? So that's good. Or even like doctors and nurses, it does show a lot of diversity today in 2026. So some of those have been corrected. An interesting one, when the GPT image generation model came out, I don't know how many people tested it, but it really went viral. And people had this prompt where they were asking GPT to basically generate an image based on, I think the prompt went something like, based on everything you know about me, generate an image what you think I look like, right? And I tested it and it gave me an image of a man, of course, of a white man, because it has a lot of context. It knows like the kind of work I do. It knows I'm an engineer. It has some details of certain projects I work on, you know. And it also knows I work with women in AI because I put in some of our things there, particularly when I'm creating social media and stuff. But still, it said it thinks I look like a white man, which was so odd. But a lot of those have been corrected. I think now what the system does, it just defaults to asking clarifying questions, which is a good kind of response, right? If we are missing context, remember the question there is whose default, right? You're missing context rather than assuming, making any assumptions. You want the system to kind of ask questions to clarify before answering. But my example here was basically asking Gemini to give me 3 pieces of advice for a father and then for a mother of young children, 1 sentence each. And the patterns that emerged were, it's interesting. If we look at the context, I know it's a bit small, you probably can't see all of that. But basically, it was telling the mother, its advice for mothers was basically prioritize like your own well-being, because you can't pour from an empty cup, right? I feel like that phrase is kind of loaded with assumptions, right? Um, Signifying like depletion, sacrifice, and then for the father really got none of that. He was basically told to kind of prioritize being present for the kids over buying expensive presents, to help build like a good foundation of security, um, you know. And I think we can also say like really it's kind of reflective of the real world that we live, right? And mothers really do experience burnout. We have like unique issues, but so the bias is not really the language that was used. I would say the bias again, as I said, is not like asking clarifying questions about the type of advice that I wanted, right? And you can also again imagine the same dynamic in like a hiring assistant or something that is asked to give like financial advice for certain different demographics, how it would perform there. The third check, failure modes. This is the final check in our audit. So we've checked our inputs, we've kind of checked the reasoning of our models, how it thinks, how it, makes assumptions and defaults when it doesn't have context. And the final one is output. And this one is where I think we all kind of are able to kind of poke our systems and see, right? So whether you're using or you're building, you have access to the outputs and you can, kind of play around with it a bit and see how it performs, right? The first question there is really like the practical application of the habits that we discussed earlier, disaggregating our inputs or our data points, right? Never accepting an aggregate. So what you want to do here is run the same task across several demographics or several languages, different contexts, and to see where the system is like lazy or clumsy, right? Where is the outputs that you're getting worse? Or where are like, as I said, I think I mentioned this earlier, where are like refusals more frequent? And where does the system now begin to make things up, right? Fabricate things differently, maybe for several users. So for example, you can ask the system if it's going back to our AI like hiring assistant, right? If we ask the system to summarize 10 CVs that are identical in credentials, but they have different names. Does the summary for some names inflate their achievements, while for others it's fabricates several things, maybe certifications and things like that, right? Essentially, is it hallucinating differently for different groups? And then, as I said, for people using systems, this is a question that you can basically run on any tool that you have access to. You don't need to be inside the model. You just need to kind of send the same task several times in different ways and see how it performs. The second question is the agentic specific one. For multi-step reasoning or agentic systems, you want to kind of run an end-to-end task and then inspect like the aggregates to the final outcome. not just each step. Here you're checking, if small biases within the system compounds, right? And this is important because agentic systems can kind of pass those biases, um, small steps, audits that you run at several different steps. They pass those, but then the final aggregate output, it fails on that, right? So again, imagine a hiring assistant, right? If maybe there are several steps, first step summarizing a CV, you notice like a small disparity there and it looks acceptable. So even like a 10 or 5% disparity, right? It's small, you can almost like an invisible error and you overlook it. The second step, maybe you're now ranking candidates against certain criteria. Again, any small disparity there looks acceptable. You move on to the next step where you're now drafting maybe outreach emails, same thing. Final step, maybe scheduling interviews. You also have issues there. Each step looks fine in isolation, but by the time a candidate has progressed through that pipeline, the compound effect can be, massive, right? So again, you want to this is kind of like the flip side of this, right? You disaggregate, but then for multi-agent systems, because those are like complex systems broken down into like smaller parts, you also want to look at the final output as well. I do have an example here, but I think we may need to skip this. And again, like all the details are in the canvas on my website. So if you're interested, just have a look and see how it works, for your systems that you're building or that you're using, right? Um, I think this is also part of the example, the worked example, drawing on patterns from the research literature. But I also wanted to be honest about what the canvas doesn't catch there, right? It does give us a clear evidence-based list of like risks that we can, very easily identify, as I said, designed to be like very quick. Um, um, so we are able to easily identify bias, risk, and, begin to think of how to take action to correct those. But then it doesn't catch certain things, right? So I just listed a few there, jailbreaks, certain legal compliance requirements. So think like the EU AI Act requirements or any other legal requirements. And then, of course, deeply technical fairness trade-offs. It doesn't catch those. You probably need like a fairness specialist to kind of review your system as well. And then another thing that it doesn't catch is overcorrection, right? So again, another viral moment back in 2024, where Google Gemini's image generator was tuned to produce more diverse outputs, and it ended up producing um, or generating racially diverse German soldiers from the Nazi era, things like that. Again, we have to kind of be mindful of. And so, you've run the canvas, you've looked at your system systematically, and you probably identify certain issues. What next, right? These are just some options you may want to escalate, particularly if you're working within a team, push it up the chain with like evidence of course, you document whatever you find, um, and escalate that. You can document, and in that process also kind of constrain the use of that system, right? So you might limit the deployments to maybe just like the internal team or restrict to certain demographics while you continue to improve. And then the last one would be like just basically if, all else fails, you basically don't ship the product, or if you're using, don't use for that specific use case. One question that I have been asked, like while I was developing this, sharing it in my network, a couple of people asked like, how does this fit into like the broader responsible AI framework that we have, right? Already existing, this again for large teams, um, you know, there are three ways, right? I've identified here. If you have like a formal framework, this canvas just basically again surfaces like the questions that you ask, right? And whatever results you get here, I have 12 specific questions and where you know your framework, larger framework might be vague, right? So this like really gives you a way to kind of narrow down your findings, and whatever outputs you get will feed into that larger body of work. Of course, if you're working within like a smaller team and you're new to bias work, this would be a fantastic place to kind of start. For developers, if you ship continuously, you want to have like these checks, you know, particularly for me, this is how I use it, constantly like running at every stage. So when you're designing the system, you want to run and check and see. And then when you make any improvements, as you test, you also check as well. No, I think I'm going back. Yeah, and so our key takeaways from today, you know, can't overemphasize this really. Aggregate scores always hide certain things, issues in our model. So, as I said, always like disaggregate your data or your like test cases and check. A good place to start, like even if you don't run the other checks, you also always want to check like for defaults, those assumptions that your system makes when it doesn't have like full context, right? And then of course at some point, if you get to kind of surface issues that are really harmful for certain demographics, you just basically um walk away. But we again, discuss like three different options, either escalating or constraining the system as well. And, these are fantastic resources. I think are also good. I would recommend you check out great resources for kind of understanding how AI bias affects the real world, right? There are several documented cases of real systems that have failed in the Atlas of AI risk. Some examples include like gender bias, even in like healthcare, the healthcare industry, different sectors. I would say it's a good place to start. I love to review it because it just gives me an intuition of what works and what doesn't work well. So it's a good place to start. All right, and thank you. That brings me to the end. I know I went a bit over, but I hope that was valuable to you. I would say check out the Canvas, check out those resources, and any questions are welcome or contributions or shared experiences. Thank you.
Thank you very much, Toma. And while I'll give you a second or two to breathe a little bit, we really
Water break.
appreciate a little bit of a break. Appreciate the session and the insights. Really, really helpful. Everyone, if there are any questions, I'd like to open it up for questions for a few minutes for the remainder of the time. And as you think about your question, I just wanted to say that I have shared a direct link to the resource that Toma used and shared with us this evening. And I've also shared our feedback form, and we'd really, really appreciate your feedback to make these sessions really the best for everyone who's attending. So those two couple of things from my side. Any questions or comments or insights or feedback?
Okay, I'll open up just because nobody's talking.
Go
Sorry.
for it, Isabel. Thank you.
Sorry, I'm a bit sick, so that's why I'm off camera. I don't look great.
Don't worry.
I had better days. I find it incredibly informative. So thank you so much, Toma. It's for me. I really wanted. I think it is just really good the fact that it goes from the pre-training um, area. If it comes with a pre-training from then, now I understand the steps. I didn't understand those steps before. So I just would like to thank you because I think it's, for me, it has been incredibly informative. So thank you.
All right, thank you so much for that feedback.
And if I can add to that, it is also something, Isabel, that I have observed, whereas that's why I think it's so important that there's a very wide representation at the table when systems are set up, because that is one way of making sure that we catch some of these at the insertion point, if I can just call it that way. But yes, very good point, Isabel. Thank you.
True. I think that is what really drives our core mission and, the vision for women in AI to get more participation, particularly from women in the AI space, get our voices heard,
Absolutely. Right. A last call.
All right.
Any other questions?
No questions?
I just wanted to say that it's been very insightful and helpful. Could you just go back one slide, because I think there were some resources, but I didn't read it. Yeah, thank you. That really
Yes.
helpful.
So, yeah, I mean, if you just Google the Atlas of AI Risk, let me see. I can stop sharing. Let me stop sharing and maybe open it up and we can just see what it looks like. But if you just Google it, you'll see like a wide range of like use cases, several failure modes. I think I'm sharing now. Yes. So this is what it looks like, right? You can see if you scroll and there's some context, the EU AI Act classifies each AI use into one of three risk levels. So you have unacceptable, high, or low risk, which are highlighted here. And then you can see incidents for each of those levels here in the atlas, right? Of course, high risk or unacceptable uses are in red, high risk in yellow, and low risk ones are blue. And you can just let's see one example, highlight. High risk, I think, will have to do with a lot with like facial recognition systems. Let's see. Yeah, so things like this, right? Where's that one? I want that to go away, yeah. Okay. And, the size of the circle will also tell you like the number of incidents that have been reported, right? So the bigger circles will tell you, more cases of these have happened, so you can just kind of see here, identifying individuals for security purposes. You can also click in and get more details about the incidents, when it happened, where it happened. And I think this also links to that AI incident report, right? Yes. So the other resource that I put in there, the incident report, is also linked here for this particular case. And so you can just open that up as well and see like details of the case. So it's really a fantastic resource, I think, for everyone, just to get awareness.
Thank you for that, Toma. Before we go, I do see there's a hand raised. Shilpi,
Oh, okay.
you wanna go ahead?
Yes, thank you so much, Thoma, for this insightful session. I have a question regarding certifications related to AI audits. Like if we want to understand NIST AI framework and EU AI Act, there is lots of material online. You also gave us very nice content related to that. But if we want to earn a certificate and we want to transition our career in that direction, then is there any suggestion from your side? In the market there are so many like AIGP is there and few
Yes.
others are there. So which one is in most demand and which one will be most useful?
I don't know if I'm in a position to say which is in most demand, but
Any
I'm aware of a
recommendation from
couple
your
of
side?
them. I'm aware of a couple of them. I know the AI Safety Institute, they have a few, particularly with like if you are looking into going into a career um in like AI governance, right? So those new AI governance roles, they have a few courses on their website. So AI Safety Institute, they have a few courses on their website I think you can take. I scanned, like just skimmed through a while ago, so I don't know how updated this info is. But I remember, like, they were really good because they take you from foundations, several different levels. It's just good to have like a structured way to learn these new things. So I would say maybe check that out. The is it a Turing Institute? They also have one. I came up across I think last year um that had to do with AI ethics. So it was an ethics course, but I know they will also have things on governance and things like that, right? So maybe also check the Turing Institute website. That might be helpful. But as I said, like, I don't know that I'm the best person to give you advice. What I can do is maybe do a bit of research. And if you reach out to me, maybe on LinkedIn, I could come back and tell you what I find, uh, you know, from my research, or I ask a few people in my network as well.
Okay, thank you, Toma. These pointers are good enough. I will work around them. And still, if I will be having any question, I will try to reach you and connect with you on LinkedIn.
Yes, that's fine.
Thank you.
No worries.
Perfect. Thank you, everybody. Thank you, Toma. I'm thinking this concludes our
Yeah,
session.
yeah. We're right on time, so this is grand. Thank
We are indeed.
you all so much, for attending and for your engagement, and leave some feedback as well. And Kota, any last words?
Absolutely. The only last words for me are, again, thank you very much. And we're really, really looking forward to seeing you next week. I think it's same time, same day next week for our third session, which I don't have the subject on now at the top of my head, but we will make sure that we will. Oh, maybe you do, Toma, because you're the queen of this. So
I think it's on AI adoption.
there you
We
go.
have a fantastic speaker. I even see her here, but I wouldn't put her on the spot. I see her in the meeting.
In our meeting, absolutely. So
I wouldn't put her on the spot right now.
yes, we
Let's
will
wait till
we
next week to hear her lovely voice.
exactly. We will keep the mystery, but we will make sure we're making a bit of noise on LinkedIn. So do follow
Yes.
us. And thank you very much once again. Enjoy the rest of your evening and see you next week.
Bye, everyone.
Bye,
Thank you.
everybody.
Bye.
Bye.